Welcome to the course of Network Protocols. This is lecture number 14 and the topic for our today's discussion is selective multicasting. I am your instructor, Dr. Zeeshan Bangash. So let's move to the agenda of our today's discussion. Before discussing details about the selective multicast protocols, in the first session of this topic, we will be talking some basic concept about multitasking, particularly IP multitasking. Then we will be discussing the model of a multicast groups, how the sending of data and joining a multicast group take place. Then we will be discussing some routing protocols for multicasting, some operations, a data flow in a routing protocol, and some ambiguities when we are doing multicasting. And then we'll be discussing some routing protocols that perform multicasting. And at the end, we will be discussing selective multicast routing protocol. So let's move to the first agenda item, that's about IP multicasting basics. So about IP multicasting, it's basically the method through which the packets are sent, or we can say that the internet protocol datagrams are sent to a group of interested receivers, and this sending is performed in a single transmission. So the sender only sends or perform a single transmission to a designated group, and any member of that group simultaneously receive the transmission. This is the diagram for a multicast operation, in which you can see this, that the sender, while sending any IP datagram, it is submitted to multiple receiver in a single transmission. However, in case of Unicast, there is a point to point transmission between two nodes or two interested positions. However, in case of a broadcast transmission, the transmission is sent to all the available receivers. So you can just check this, that in the diagram the information is transmitted to all the receivers that exist, and this is a sort of a broadcast transmission. Now about multicasting or IP multicast. IP multicast is specific for IP packets, and no other form of packets can be considered. And this IP multicasting has application in different streaming media apps, like the Netflix or the HBO now, or different applications like TEDx talks that are available on the internet. So this IP multicasting mechanisms are used in these applications. So there is a specific block in IP version 4, we know this from our previous knowledge that this range, that is 224.0.0.0 up to 239.255.255.255, this block in IP version 4 address domain is reserved for multicast operation, or we can call it a multicast address block. Similarly, there is again some reservation in IP version 6 block. This is IP version 6 block for multicast operations. So a specific block is reserved for multicast operations. Now, some protocols that are associated with IP multicast includes IGMP, a known protocol, which is the Internet Group Management Protocol, and another protocol which is Protocol Independent Multicast and Multicast VLAN registration. So these are some of the IP multicasting protocol that exist in the literature and implemented in different applications in different scenarios for multicast operations. However, this IGMP, a known protocol, is used to manage this IP multicast traffic on the layer 2 networks, or we can say that where there is layer 2 switches installed. So the IGMP protocol is used for managing the traffic there. Now, another important point, that RFC 1112 describes this IP multicasting mechanism, and it was first standardized in 1986. Now, again, multicasting or IP multicasting uses network infrastructure efficiently. How? By sending the source to send a packet only once, even if it needs to be delivered to a large number of receivers, and that receiver's number can be from tens to hundreds to thousands. So the sender only sends one packet, it, and it need not to send to the thousand receivers independently. So a single transmission will help to transmit this information to many and multiple receivers at the same time. The nodes in the network, particularly the nodes, means that the intermediate nodes, that may be the switches or the routers, that take care of replicating the packet to reach multiple receivers, such that the messages are sent over each link of the network only once. So it's not the responsibility of the sender to transmit the packet at multiple links, but the intermediate nodes, that are basically the switches and the routers, that take care of sending or replicating the packet on multiple interfaces to enable them to reach at the multiple destinations or at the multiple receivers. Now, common transport layer protocol to use multicast addressing is the UDP, which is a sort of unreliable data transmission protocol in which there is no guarantee whether the data is received at the receiver. However, it's not reliable because it's not guaranteed that the message is delivered or it is delivered in order. However, another protocol, which is the PGM or Pragmatic General Multicast, have been introduced that has added reliability to the IP multicasting, and that is developed to add loss detection and retransmission on top of IP multicasting. So it's another it's a feature added to an IP multicasting, which is the PGM protocol. Now, IP multicasting or the multicast group sending and joining. An IP multicast group address is used only by the sources or a source, and it is also used by the receiver to send and receive multicast messages. So how it is done? First of all, let's talk about the source. The source uses this group address, it's the only single address, as in IP destination address in their data packets, and it's a single one-time transmission by the source destined to this IP address, which is basically the address of that group. Now, about that receiver, this receiver uses this group address to inform the network that they are interested in receiving packets sent to that group. So the receiver needs to register itself to that group. So anything, any information that is being destined to this group will be received by these receivers. Now, for example, if some content, for example, a data or a file that is associated with a group 239.1.1.1, which is an address of a multicast group, the source only need to send that file to that single destination, that is 239.1.1.1. It's a single transmission. So receiver of that content will inform the network that they are interested in receiving data packets. So all the receiver, as we have discussed already, need to register with that group earlier before this transmission. So whatever, so the receivers first of all joins this 239.1.1.1, and after the joining it will start receiving the packets. Now the protocol that are typically used by these receiver in order to join this group is basically called the IGMP, which is the Internet Group Management Protocol. So this protocol is used by the receiver in order, and this protocol provides a service for its receiver to join any multicast group. Now about some routing protocols in an IP multicasting. So in routing protocols context, the routing protocols are based on shared trees mechanism. So once the receiver joins a particular IP multicast group, so it's basically the first step, a multicast distribution tree is constructed for that group. And the protocol that is more widely used for that is for multicast distribution tree creation, is the PIM protocol, which is the protocol independent multicast. So this is an interesting mechanism, that the PIM protocol basically construct a tree or a distribution multicast distribution tree. Now it tries to set up multicast distribution trees so that the packets from the sender, or the data packets from the sender to that multicast groups needs to be received to all the receiver that have joined that group. Uh, One important point to be considered is that the IP multicast operations are receiver driven. What does that mean? So let's discuss this thing. The IP multicast operation does not require active source to know about the receiver of the group. So the source only sends the information target to a multicast group IP or a destination. So the receivers only needs to have a prerequisite operation, that they needs to be member of that group. The multicast tree construction is, again, as we discussed, is a receiver driven, and that are initiated by network nodes which are close to the receivers. Now the IP multicast is scales to a large receiver population. Now, there's a famous saying about internet architecture Dave Clark that discusses this IP multicast model as it's basically when you put packets at one end and the network conspires to deliver them to anyone who asks. So this is basically IP multicast model. Now let's look into this diagram of IP multicasting, how it performs its operation. So there is a sender, and this sender sends information to a particularly node, which might be a switch or multicast switch or a router, and it just sender sends only one single time transmission to target toward that multicast group, and then that switch or that node uh, basically transmits it to multiple interfaces to which of all the receivers who are member of that group. Now each host that wants to receive members of a multicast group, that is the received data correspond to a particular multicast, must use IGMP to join. We have already discussed this thing, that this protocol is used for by the receiver in order to join any group. Now adjacent routers also use this protocol to communicate. However, in case of unicast routing, each router examines the destination address of an incoming packet, and then and process it by looking up the destination in a table in order to determine which interface in order to use to send the packet to get closer to its destination. So here, in case of unicast routing, the source address is irrelevant to the router. So this is basically the difference. However, in multicast routing, the source address is used to determine the data stream direction. So this is the main difference between a unicast routing and a multicast routing, that the source address is not important in case of, is irrelevant in case of unicast. However, this source address is used to determine on which the data needs to be streamed, or to identify the data streaming direction. This source address is used. The source of multicast traffic is considered as upstream, and the router determines which downstream interfaces are destined for this multicast group, and also the packets that are to be sent through the appropriate interfaces. The mechanism of reverse path forwarding that we have already know from the knowledge of routing protocol is used to describe this concept of routing packet away from the source rather than forwarding it toward the destination. So this term routing reverse path forwarding terminology that is used in routing protocol design is used here for this for this perspective. Now, there are some problems when you're doing IP multicasting. Like, there always um, a threat of launching any attack within the network. Since we know that a number of errors can happen if a packets that is intended for a unicast and due to some reason accidentally sent it to a multicast group, so there are so this error is possible. And for example, in particularly for example, if ICMP packet to a multicast address has been used in the context of DOS attacks as a way of achieving packet amplification. So this is a sort of attack that can result in this IP multicast mechanism implementation. So this is there is some challenges that need to be considered, and that needs to be carefully designed. Now, there's some common delivery and routing protocols that are used for multicast distributions that exist in the literature are the IGMP protocol. We already talked about that. Another protocol is the protocol independent multicast. We talked already about this. And then a distance vector multicast routing protocol that's used in most of the routing design, and we know it from the previous knowledge. Then there is a multicast open shortest path first. uh, Another routing protocol is the multicast BGP and a multicast source discovery protocol, multicast listener discovery protocol, and there's another selective multicast protocol which is part of our topic that we are going to discuss, that is the uh, JRP multicast registration protocol, which we call it as GMRP. And this GMRP is basically the selective multicast mechanism we will be discussing in the next lecture about the selective multicast mechanism. However, on local networks, multicast delivery is controlled by basically the IGMP, and it's specific for IP version 4 traffic. So for LAN, the controlling of multicast is through IGMP, and for IP version 6, this MLD protocol, which is the multicast listener discovery protocol, is used for controlling the multicast delivery. However, inside a routing domain, the PIM, which is the protocol independent multicast, and the MOSPF, which is the multicast open shortest path first protocols, are used for controlling the multicast delivery. Also, between two routing domains, or the inter-domain multicast routing protocol, MBGP, which is the multicast BGP protocol that is used. However, for selective multicast, GMRP, which is the Garap multicast registration protocol, is used. And this is the topic that's part of our course, and we'll be discussing in the upcoming lecture, and we'll discuss this thing in detail. And currently, for this session, this is the reference from which the content has been taken, so you can consult this. And thank you very much for patiently listening. Take care. Allah Hafiz.